Hello everyone, welcome back to the Infinitus Dhruv. Today covering most of the concepts of the Kubernetes from basic to advanced with examples. I will tell you how IT industry has reached to the Kubernetes and why it is required. So let's begin. So table of contents includes evolution of IT industry, introduction to Kubernetes, features of Kubernetes, Kubernetes architecture, Kubernetes installation, Kubernetes components, and dashboards. So these are the main topics which we will be going to cover, and inside it lot many subtopics are there which we have included it like deployments, services, pods, replica sets, replication controller, and lot many more. So this slide we have added because we wanted to explain it from beginning how evolution is happening in IT industry, how we have reached to Kubernetes, what all other things were there in the past. So short intro of the evolution we are going to cover here. As we all know that the cloud regime supreme, like everybody is talking about the cloud technology, and as we all know that containers make an app deployment as easy as ever, and developers work directly with the operations team right now. There has been a lot of changes in the development and deployment since 80s till now. We can trace the evolution of how organizations have developed and deployed and manage applications over the different distinct phases. So if we can see that in the 80s and mid 90s, data centers and physical servers running monolithic applications developed using traditional waterfall methodologies. Late 90s to 2000, data centers and hosting providers running Linux and Unix servers. The emergence of the virtualization technology like VMware, KVM running multiple tier applications developed using agile methodologies. Then in 2010 to nowadays, cloud increasingly replacing applications into microservices running on a container infrastructure managed and orchestrated by Kubernetes. Developers and operations collaborating using DevOps methodologies. So for development process, I think most of the people had heard about the Sdlc, that is the software development lifecycle. In initial days when the software development started, then we started it with a waterfall model. There are a lot more methods that time, but this is one of the oldest model I think. And in this model, we have to take all the requirements at once and started developing the software, which takes lots of time. It has lots of disadvantages as well as some advantages. Then after a decade, we jumped into the agile methodology, which is much better than the waterfall because it has good response or feedback time as compared to the waterfall. We can work in sprints and release it in 2 to 3 weeks time. Then nowadays we are following the DevOps culture, which is filling up the gap between the developers and the operations team. Then if we can see in the application architecture, in monolithic architecture, all these components coexist as a single module by and managed by a single team every time, which is bundled together. If you need to update any of the deployment for the entire application, and this is really slow down the changes for the large and complex application. But for the smaller application, monolithic architecture is often the best solution. And if we can see for the multi-tier application or a three-tier application, it is a client-server architecture with a physical server coexisting of the physical layer, application layer, and the database layer. Presentation layer, that means a user interface, example Nginx, IAS, Angular, or a JavaScript. Application layer, it is a business logic, you can say, and some of the example like Java, .NET, Python. For the database layer, as we all know that we have the Oracle, MongoDB, NoSQL, etc. Then if we can see about the microservices, it is a separate our the application into the smaller set of interconnected services rather than building one monolithic application. Each module supports a selected business goal and uses a simple and well-defined interface to communicate with each other set of services. Each microservice has its own database sometime, or they can share multiple. So if we can see in the application infrastructure, this one I will discuss in the next slide. Then next we have the deployment and packaging. A data center is any location or accessible by the members of the enterprise that controls the hardware and device that can run internal network, that host digital systems and applications and can store data. The next we can see the hosted services. These are the technology services offered by the provider hosting physical servers that are removed from the customer premises, and the hosting service provider owns the overseas infrastructure, software, administrative tasks at a private location. And I think most of the people is aware of the example of these kinds, like we are using all the things over the internet, like VPN, remote desktop. Some of the we have heard about the elements of the hosted service, like software as a service, platform as a service, infrastructure as a service, right? Then the next one is the cloud services. So I think cloud services are the subnet of the hosted services because these cloud applications are the web enabled. That means instead of being based on the physical hardware, they are based in the shared virtual environment and that are all managed by the cloud hosting providers. Okay, some of the benefits of the cloud services, like we can scale the solution and these are the cost effective, right? Okay, so in this slide, we can see the differences between the servers, virtual machines, and the containers. Okay, so servers are the physical servers. They are basically a typical computer. They are mostly the larger what you may think about it. Physical servers are powerful computers as usually stored in a data center for the business use cases that runs the operating systems and applications of their internal hardware resources. Some of the resources include the RAM, CPU, SDD or SDD, or the network connectivity, and many more. Then comes the virtual servers. Virtual servers are the set up with this something called the hypervisor. Okay, so which is the type of the software or the operating system this that create and runs virtual machines. Okay, so if we install the hypervisor, we can use it for the virtual servers with their own virtual compute resources. We have the two types of hypervisor, like type 1 and type 2. So the main difference between the type 1 and the type 2 hypervisor is that type 1 hypervisor runs directly on the host hardware, while type 2 hypervisor runs on an operating system similar to the other computer programs. If we talk about some of the examples, then Microsoft Hyper-V or VMware vSphere and Oracle VM Server are some of the examples of Type 1 hypervisor, while VMware Workstation, Oracle VirtualBox, and the Parallel Desktop for Mac are the example of the Type 2 hypervisor. Then at the end, we have the containers. Containers are the lightweight packages of your application code that are bundled together with the dependencies such as a specific version of a computer programming or the language runtime or the libraries required to run that particular software. So I think popular example of the container technology is the Docker, and we have heard about it that the Docker we can build, ship, and run any app anywhere. Okay, so I can give you one example that why this Docker comes into picture. So there, in my previous organization, there's a bunch of developers who are working on some of the application, Java application. They have written their code and everything was working on their machine. And when they have handed over their code to the operations team for the deployment purpose, that code was not working in their environment or their system or a computer. So then they got to know that there are some dependencies, like they were using a different version of Java and they have some missing libraries over there. So because of that reason, that application was not running and failing at the deployment side. So to overcome these problems, this container thing comes into the picture, and there is a whole lot many stories like C groups and all, and it was already there in the Linux, but a Docker is working in the same way. So what it is doing is it is creating a shell or a container kind of thing where it only includes the dependencies which needs to run the application. And the same bundled, you can create the Docker images, and the same image can be copy and pasted to the multiple locations or sent to the different servers, and they can directly run the Docker run command and your application gets start deploying. So next we have the container orchestration. Container orchestration basically automates the deployment, management, scaling, and networking of containers. Top three container orchestration engines in the market right now are the Marathon by Apache Mesos, Docker Swarm, and Kubernetes. So, Kubernetes is the open source container orchestration software. It was originally developed by Google. It was first released on July 21st, 2015, and it is the ninth most active repository on GitHub in terms of number of commits. But before that, also Google was using the same concept with a different team, that is a board, and then they have handed over this project to the CNCF. So now CNCF are managing this project. We have some features of the Kubernetes and we will discuss it one by one. So first is the automate various manual processes. So that means Kubernetes will control for you which server will host the containers, how it will be launched, or etc. Second is the self-monitoring. That means the Kubernetes checks constantly the health of the nodes and containers. Third is the horizontal scaling. Kubernetes allow you to scaling resource not only vertically but also horizontally, which is very easily and quickly. Next is the automated rollouts and rollbacks. So if after a change to your application, something goes wrong, Kubernetes will roll back for you, and this is a very good feature in Kubernetes. Next is the container balancing. So Kubernetes always know where to place your container by calculating the best location for them. Next is the network services. So Kubernetes offers security, networking, storage services, each one. Next is the storage orchestration. Kubernetes also provides the mounts and the storage system to your choice to run your applications. So let's see some of the differences between the Docker Swarm and Kubernetes, because these are the two main container orchestration technologies which are currently used by most of the organizations. So in Docker Swarm, if you can see, it is very easy to install and initialize, but in Kubernetes, it is really very complex procedure to install the Kubernetes, because in Kubernetes we have multiple sets of commands which we need to run, like installing the packages, certificates, and all. So it is really a lengthy process and very complex. Secondly, Docker Swarm is not that much reliable and has very less feature. But in Kubernetes, as we have already discussed, Kubernetes is having lot many features, which is much more far good as compared to the Docker Swarm. In Docker Swarm, it cannot do the auto scaling and load balancing of traffic between containers in a cluster. But in Kubernetes, we can do the auto scaling and can do the load balancing by the manual intervention traffic between the containers and the pods. Next, we can do the rolling update, but cannot do the automatic rollbacks in Docker Swarm. But in Kubernetes, we can do both. In Docker Swarm, we have to use third-party tool for the monitoring purpose like ELK and others. But in Kubernetes, it has inbuilt feature by which we can do the logging and monitoring. Next is in Docker Swarm, we don't have the GUI, but in Kubernetes, we have a feature of GUI called Dashboard, from where we can see all the details of our cluster like pods running, pod failing, deployment, cron jobs, everything. So let's talk about the Kubernetes architecture. So you can see we have the master and the slave node concepts in the Kubernetes. So we can have single master and single node, or single master multi-node, or multi-master setup. Okay, and we have multiple components inside it. So let's see. So in Kubernetes architecture, and this offers a loosely coupled mechanism for service discovery across a cluster. Kubernetes cluster has one or more control planes and one or more compute nodes. Overall, the control plane is responsible for managing the overall cluster, and it basically exposes the APIs and for scheduling the initialization and shutdown on the compute nodes based on the desired configuration. Each of the compute nodes runs a container runtime like Docker, or which runs with an agent like Cubelet, which communicates with the control plane. Each node can be bare metal server, or on-prem server, or cloud-based VMs. First is Kube API server. As its name suggests, the API server exposes the Kubernetes API, which is communications central, external communication via command line interface or other user interfaces passed to the Kube API server, and all control planes to node communication also goes through the API server. Next is the etcd. etcd is like a key values pair that stores all the data related to the cluster. etcd is highly available and consistent since all the access to the etcd is through the API server. Information in etcd is generally formatted in human readable YAML form. Next is the kube scheduler. When a new pod is created, this component assigns it to a node for execution based on resources, requirement policies, and affinity specification regarding geolocation and interference with other workloads. Next is the kube controller manager. Although a Kubernetes cluster has several controller functions, they all are compiled into a single binary known as a kube controller manager. Controller functions include in this process includes replication controller that ensures the correct number of pods is in existence for each replication pod running in the cluster. Then node controller that monitors the health of each node and notifies the cluster when nodes come online or become unresponsive. Next is the endpoint controller that connects pods and services to populate the endpoint objects, service account, and token controller. This allows API access tokens and default account to new namespace in the cluster. Next is the kubelet. So every node has an agent called Cubelet. It ensures that the container describes its pod specifications that are up and running properly. Next, we have the kube proxy. So a network proxy on each node that maintains network nodes, which allows for the communication from pod to network session, whether inside or outside the cluster, using the operating system packets and that are filtering.
So for the Kubernetes installation, we have lots of options present. Some of them are like kubeadm, that is basically used for the bare metal installation. Then we have the minikube, which is for the virtualized environment for Kubernetes. Then we have kops, that is for the Kubernetes on AWS. Then on the GCP side, we have the Kubernetes on GCP. Okay, and this is the website mentioned where you will find all the documentation to install the Kubernetes. Next is the pod. So by encapsulating one or more applications container, pods are the most basic execution unit of the Kubernetes application. Each pod contains the code and storage resources that is required for execution and has its own IP address. Pods include configuration option as well. Typically, a pod contains a single container or few containers that are coupled into an application or a business function. For example, if you can see in the screenshot, pod which consists of the container running the image Nginx with a version of 1.14.2. In terms of Docker concepts, a pod is similar to a group of Docker containers with shared namespace and shared file system volumes. Let us see some of the uh, demo related to the pod, how we can create a pod in the Kubernetes system. So currently I have this cluster running with one master and one node, kubectl get nodes. Yeah, so we have a control plane and a slave, and I have one pod configuration. Let me copy it and create a YAML file for this. Let's paste that. So we have the API version v1. All the syntaxes are given in the Kubernetes documentation. Kind, we are using pod. So initially it is for pod. In the future lecture, we will find that we have multiple kinds, like we have pod, services, deployment, replica sets, all. Here in the metadata section, we have just mentioned the name, and this name will be visible in the pod description. Then we have the specifications, like which name of the image using, what is the version of the image, and on the port where it is listening. Okay, give the permission. So command is kubectl apply -f and then the file name. So it will create a pod, and to check if that pod is created or not, so see here it has created a pod name Nginx, which is running from the last 8 seconds. We can do the describe command as well, kubectl describe pod and the pod name. Okay, here you will find lot more data. We have the namespace, that is the default. We have the start time, label, IP address, mount points, and what are the steps it has created. So it has basically pulled the image from the Docker registry, and then it started that particular pod. So next is labels and selectors. So what is label? Labels are the key value pair which are attached to pods, replication controller, and services. They are used as identifying the attributes for objects such as pods and replication controller. They can be added to an object at creation time and can be added or modified at the runtime. Example for the labels are like, let's say we have defined the releases, and it can be stable release or a canary release. Next is for the environment. If we have multiple environments, we can define the label like dev environment, QA environment, production environment. The same way we have tier like front end or a back end. So in this screenshot, you can say uh, here the configuration file for a pod has two labels: environment equal to production and app equal to the Nginx. So if you wanted to list it on the basis of this labels, we can give a command called kubectl get pods -l, that means the label, and environment equal to the production. So it will list out all the pods which are having the labels, that is the environment equal to production. Next is the selector. So labels do not provide uniqueness basically. In general, we can say many objects can carry the same labels. Label selectors are the core grouping primitive in Kubernetes. They are used by the users to select a set of objects. I will give you an example to understand more about the labels and selectors. So let's come to this console, that is the AWS console. Here I have some instances created. All are in the stop state. We don't require that. I just wanted to show that here in the Jenkins, if you can see, in the tag section, what I have done is I have given a label. Tags basically are the label here. env equal to prod. The same way for this ACE server, I have the tag. Okay, I don't have the tag. Let us see for the Kubernetes. I have the tag prod. Again, for the Docker, I have the tag dev, and at the Ansible, I have the tag dev. Okay, so these are the labels which I have given to my instances. So what means the selector? Selector means like we can do the filtering on that basis of the label. So here, if you can see, I have some parameters like environment. Okay, so in the tag section, we have the name and the environment. So on that basis of the environment, I can search for the particular pod in case of Kubernetes. So if you will give the value to the pod, you will uh, get the output related to that particular label and selector, right? So if you wanted to list out all the um, instances having the value of dev, then it will give out the result. The same way it works in the Kubernetes, we have the labels defined, and then on the basis of the selector, we can give our parameters and get the output accordingly. This is required because most of the cases in the bigger organization, we have tens of thousands of the containers or the pods running, and we have to distinguish it on the basis of something, and that is we require the labels and selector. Okay. So next topic is Kubernetes namespace. So namespaces are a way to organize cluster into the virtual subcluster. They can be helpful when different teams or projects share a Kubernetes cluster. Any number of namespaces are supported within a cluster, each logically separated from others, but with the ability to communicate with each other. Namespaces cannot be nested within each other. So get the command to know how many namespaces we have. That is the kubectl get namespaces, and we have some default namespaces. Let's see in the console. Kubectl get ns, that is the namespace. So yeah, by default, we Kubernetes provide these four kinds of namespaces. Let's discuss about it. So the default namespace for the that is basically for the objects with no other namespaces. Kube system, it is for the objects created by the Kubernetes system. Kube public, this namespace is created automatically and is readable by all users. This namespace is mostly reserved for the cluster usage in case that some resources should be visible and readable publicly throughout the whole cluster. Then we have the kube node lease. This namespace holds lease objects associated with each node. Node leases allow the kubelet to send heartbeats so that the control plane can detect node failure. Okay, let's see some demo how we can use it and implement in the projects. So as we have seen that we have created a pod. Okay, so this command will list out all the things which is in the default namespace right now. Okay, so when we have done the cube ctl describe pod, then nginx. Okay, so here it has mentioned the namespace default. Okay, let us see if we create a new namespace and we just wanted to create a pod in that particular namespace. So to create the namespace, we have the command kubectl create namespace dev. Okay, then c kubectl get namespace. So we have now dev namespace created. Okay, and now we wanted to create a pod in a particular namespace. So I have one YAML file. Okay, so here we need to change it to the dev, then copy the whole content, create vins.yaml, paste the content, save it, give the permission, then run that kubectl apply -f namespace.yaml file which we have created. Now run the kubectl get pod command. Yeah, so still it is showing uh, Nginx pod here because I have not mentioned, and basically if you will not mention, it will give the result for the default namespace. Then for this thing we need to run kubectl get pod -n and the namespace name. Yeah, so we have created a dev namespace, and yeah, for dev we have my pod running. You can do the kubectl describe pod and the pod name, that is the my pod, kubectl describe pod my pod. Okay, okay, sorry, I have not specified the namespace. Yeah, so by this way we can get to know more about it by using the describe command. So here it is showing the namespace dev, it is running in a particular namespace. Okay, so next topic is the replica set and the replication controller. Okay, so let's assume we had a single pod running our application. Okay, what if for some reason our application crashes and pod fails? Then user will no longer be able to access our application, right? So to prevent the user from losing access to our application, we would like to have more than one instance or pod running at the same time. That way, if one fails, we still have other application running on the other one. The replication controller helps us to run multiple instances of a single pod in a Kubernetes cluster, and that is the reason it provides a high availability. So, does that mean you can't use a replication controller if you plan to have a single pod? The answer is no, right? Even if you have a single pod, the replication controller can help by automatically bringing up a new pod when the existing one fails. Another reason we need replication controller is to create multiple pods to share the load across them. Replication controller and replica set both have the same purpose, but they are not same because replication controller is the older technology that is being replaced by replica set, and replica set is basically a new recommended way to set up the replication. There are only minor differences in the way each works. Replica set is also known as the next generation replication controller. Uh, if we can talk about the differences, we can see that in replica set and the replication controller is the selector type. Okay, replication controller basically supports equality based selector, whereas the replica set supports equality based as well as the set based selector. So now, what is the equality based selector? So equality based selector allows filtering by label, keys, and values. That is, we have three types of operators to be selected that are equal to, double equal to, and not equal to. Here we can see in the example it selects the all the resources with key equal to environment and value equal to production. Second one selects all the resources with key equal to tier and value that is distinct from the front end. Now, second is the set based selector. So set based selector allows filtering keys according to the set of values. Here also we have three kinds of operators used in the set based selectors, and those are in, not in, and exist. Here in the first example, selector will select all the resources with key equal to the environment and value equal to production or QA. In the second example, that selects all the resources with key equal to tier and value other than front end and back end. Replica set is very similar to the replication controller. As usual, first we have the API version, then kind, metadata, and spec. The API version, though, is a bit different. It is basically the app slash v1, which is different from the replication controller. For replication controller, it was simply v1. If you are putting the wrong value, you are likely to get an error that gives no match of kind replica set. Okay, so let us see some of the example of the replica set, how we can create a multiple instances of that. Okay, so I have some YAML file ready. So yeah, firstly we can understand what this YAML file is having the content. So here we have the API version, then kind replica set, then we have some labels, and the most important is the replicas. So here we have mentioned replicas equal to 4. Let's copy and see how this basically works. So let us create a file called replicaset.yaml, paste the content, okay, give the permission, kubectl get rs means replica set. Currently we don't have any replica set. Just run this file, kubectl apply -f, that the replica set. Now check kubectl get rs. Now a replica set got created with 4 uh, desired value, 4 current value, 2 are in ready state. Let's see the status of the pod. Yeah, currently we are having 4 pods running. Okay, this was the older one. Okay, we can do the kubectl describe replica set front end. Here we can see that replica's value to 4 pod, all pods are in the running state. And yeah, okay. So let's assume if you want to scale up or scale down this replica set, how we can do that. So we have a command kubectl scale replica is equal to that particular value which you want to scale up or down, and then the file name. Let's try to execute that command. Okay, yeah, so currently we are having 4. Let's try to do the describe command and see what is the output. See, replica's value changed to 6, 4 in the running, 2 in the waiting. Check out the pod status. Okay, some of them got evicted. Let's wait for some time. Again, do the describe command. Yeah, 2 in the waiting state. Okay, let's see the kubectl get. I think something went wrong to the system. Okay. Mm-hmm. Okay. I think there is lots of load on this system now. Yeah, it is showing most of them are in the evicted and the pending state. Let me reduce it to 1 and see whether it's working or not. Then do the describe command. Yeah, now the current we required 1, 4 in the running state. Let's wait for some time. Okay, only 1 in the running state right now, and this the old one. Let us remove this kubectl delete -f pod. Okay, now to the get pod. Okay, only first is in the running state. Again to the describe. Okay, cool. So by this way we can do the scale up and scale down, and those evicted thing happen due to some load on this particular machine. Actually, I'm using the play with Kubernetes, and sometimes it shows these kind of issues. Next is the deployment in Kubernetes. Okay, so for a minute, let us forget about the pods and the replica set and other Kubernetes concepts, and talk about how you might want to deploy your application in the production environment. Let's say, for example, you have a web server that needs to be deployed in a production environment. You need not one, but such multiple instances of the web server running on for the obvious reasons, right? Secondly, when newer versions of application builds become available on the Docker registry, you would like to upgrade your Docker instances seamlessly. However, when you upgrade your instance, you do not want to upgrade all of them at once. This may impact users accessing your application, so you may want to upgrade them one after the other. And the kind of upgrade is known as the rolling update. Suppose one of the upgrade you performed resulted in an unexpected error, and you are asked to undo the recent update. So you would like to able to roll back the change that were recently carried out. Finally, say for example, you would like to make multiple chances to your changes to your app environment, such as upgrade and underlying web server versions, as well as scaling your environment and also modifying the resources allocation, etc. You do not want to apply each change immediately after the command is run. Instead, you would like to apply a pause to your application and in particular environment, making the changes and that resumes so that all the changes are rolled out together. All of these capabilities are available with the Kubernetes deployment. Let us see some of the deployment examples. Delete replica set -f. Oh, sorry. Okay, so we need to create one deployment YAML file. So it looks similar, but here the kind will be changed to the deployment. Let us create the deployment YAML file. Paste the content. Run that file. Okay, so in case of deployment, we can check with the same command kubectl this get deployment. Yeah, so it is showing we have a deployment created name front end. So in case of deployment, there is the another two things which got created. kubectl get all command will show you all. Yeah, so this deployment basically created four instance of pods because we have mentioned four replicas in that file, right? Here, these value. Then we have a deployment itself created and a replica set created. Okay, service didn't create by its own. We need to create the service. Okay, so the next part is the deployment strategies provided by the Kubernetes. Before we look at how we upgrade our application, let's try to understand the rollouts and versioning in the deployment. Whenever you create a new deployment or upgrade the image in an existing deployment, it triggers a rollout. Okay, so a rollout is a process of deploying or upgrading your application containers. When you first created the deployment, it triggers a rollout, and a new rollout creates a new deployment version. Let's call it a revision 1. In the future, when the application is upgraded, meaning when the container version is upgraded, it is a new one. A new rollout is triggered and a new deployment a revision is created by the name revision 2. This helps us create track of the changes made to our deployment and enables us a rollback to a previous version of the deployment if necessary. You can see the status of your rollout by running the command kubectl rollout status followed by the name of the deployment. The same way to see their revision and history of the rollout, run the command kubectl rollout history followed by the deployment name, and this will show you the revision. So there are two types of deployment strategies. Say for example, you have 5 replicas of your web applications instances deployed. One way to upgrade these to a newer version is to destroy all of these and then create a newer version of the application instances. Meaning, first destroy all the 5 running instances and then deploy the 5 new instances of a new application version. And the problem with this is that you can imagine is that there will be a downtime at that particular moment of time, right? This strategy is known as the recreate strategy, and thankfully, this is not the default deployment strategy. The second strategy is we do not destroy all the instances at once. Instead, that we take down the older version and bringing up a newer version one by one. This way, the application never goes down and the upgrade is so much easy. And as we know that this is the uh, default strategy given by the Kubernetes. Let's see some of the demo, then we will get to know uh, more idea about it. Okay, so for that, I just wanted to show you how this basically created and how the status looks like. Okay, so let me copy this command and firstly do the deletion kubectl delete -f, then deploy thing. It deleted all, then again I will apply and then I will run this status command. Okay, so this status command will show you the steps performed by the Kubernetes to see how this replicas will be created and deployed. Okay, so it will show you how many replicas it has created and how many are there in the uh, creation step. So we have the another command called history, in which it will show you the revisions. Okay, so here it is showing a revision as none. This is not capturing right now. For that we need to again destroy the deployment, then again do the apply command with the record parameter. Okay, now if you can see the history, you will get the revision with some value which we have passed. Okay, the next step, I just wanted to okay, one more thing. I wanted to show that kubectl describe deployment front end. So here, if you can see, we have the image name Nginx, right? I just wanted to upgrade this image name at a particular version. So let's say we have a command where we are updating the value to, let's say we want it Nginx version 1.20. Okay, it got updated. Let's see the status first. Yeah, so now uh, it is following the default strategy, that is the rolling update strategy. Yeah, here also you can see strategy type is rolling update, this one, and this is the default one. I haven't mentioned anywhere. So by this way, whatever I have explained you, that it will create a newer instance and then one by one it will pull down the instances or the pods, and parallelly it will work, right? So now we have the status, then we can have the history 1 2, and then again I just wanted to update the version to 18. Again, just check the describe. Here you can see Nginx version changes to 1.18. Again, if you can see the history, you will find the revision 1, 2, and 3, right? Now, notice one thing. Now I will be running the rollback command. So currently we have 1.18 at this third step, right? Now we have to roll back to the second step, and it will make the version of the Nginx from 1.18 to 1.20, the previous one. So I just wanted you to notice this thing, this revision. Okay, let me run the rollout command. Rollout undo is the command to do the rollback. Okay, it is rollback. Just run the describe command again, and you will find the previous version. And the most importantly, I just wanted to show the history command. See, firstly we were having 1, 2, and 3. So the second step got rolled back, and it just generated a new step, and it has given a new version and revision history for that, and it got updated the Nginx image version as well. Okay, so by this way we can just use the rolling update rollout feature in the Kubernetes, and that is very easy, and we can just do the undo command to roll back it. So the next topic is the networking in Kubernetes. Okay, all the containers or pods in the Kubernetes cluster must be able to communicate with each other without having a configure the NAT, and all nodes must be able to communicate with the container, and all containers must be able to communicate with the nodes in the cluster. So Kubernetes expects us to set up a networking solution that meets all these criterias, and we don't have to set it up all on our own, as there are multiple pre-built solutions available in the market. So some of them are like Cisco, Cilium, Flannel, VMware, NSX, and Calico. So depending on the platform we are deploying our Kubernetes cluster, we can use any of these solutions. For example, if we were setting up the Kubernetes cluster from scratch on our own systems, we may use any of these solutions like Calico, Flannel, etc. If we were deploying a VMware environment, then we require the NSX. And if we look at this Play with Kubernetes lab, which we are using right now, they are using the VNet. Depending on our environment and after evaluating the pros and cons of each of these, we may choose the right networking solution. With the Calico network setup, it's now manage the network and the IPs in our nodes and assign a different network address for each network in the nodes. This creates a virtual network of all pods and the nodes. They were all assigned a unique IP address, and by simple routing technique, the cluster network enables the communication between the pods or nodes to meet the network requirement of the Kubernetes. Thus, all pods can now communicate with each other using the assigned IP address. The next one we have the services. So in Kubernetes, services is an object same like the pods, replica sets, and deployment we have seen earlier. One of its use case is to listen a port on a node and forward request on that port to a port on the pod running with the web application. Okay, so this type of service is known as the node port service because the service listen on a port on the node and that forwards the request to the pod. So we have the multiple types of services provided by the Kubernetes, and let us discuss one by one. First is the cluster IP. So it is the default service type in the Kubernetes, and in this service Kubernetes creates a stable IP address that is accessible from all the nodes in the cluster. The scope of this service is to confine within the cluster only, and the main use case of this service is to connect our front-end pod to our back-end pod, as we don't want to expose the back-end pods to the outside world because of the security reasons. The second one is the node port. So a node port exposes the service on each node's IP at a specific port. Then a node port builds on the top of the cluster IP to create a mapping from each worker node's static IP and on a specific port. And then we can contact the node port service from the outside cluster by requesting the node IP colon the port number. The only main use case of the node port is to expose our pods to the outside world, and there is a limit for this node port, that is we can that port ranges from the 30,000 to 32,767. The next one is the load balancer. So the load balancer is a standard way for exposing our nodes to the outside world of the internet. We have multiple pods deployed on multiple nodes. To access our application, we can use any of the public IP of any node and the port number. But there are some problems in this scenario, like which node's IP we will provide to the clients and how the traffic balance for the multiple nodes into the cluster. So for this, a simple solution is the load balancer. Okay, let us see some of the example of the services. So I have all three kinds of YAML file ready. We have the cluster IP, then the node port, and the load balancer. Okay, so let us see if we have anything here. Okay, we have the deployment. Let us delete this kubectl. Okay, everything is deleted now. Okay, great. Now, for this, we need to create the service. So for that service, we required a deployment. Okay, so let us create a deployment for Nginx. It is created. Let us check. Okay, so for this deployment, Nginx, it got created a pod, a deployment, and a replica set, right? Now we have to map and get the output from each services. Let us see for the cluster IP, visvc.yaml, paste the value, save it, run that, kubectl svc. Okay, kubectl apply -f. It got created, kubectl get svc. Yeah, so this first one, Kubernetes, was the default one. Second one created just now. So if you wanted to see and the output, we only require the cluster IP. We can do the curl command with the port number 80. See, we are getting the output. Welcome to the Nginx. So Nginx is currently running on this cluster IP with the port number 80. Okay, just delete it, kubectl, delete -f svc. Okay, now let's check the second example. For this, we will be creating the node port kind of service, visvc. Okay, run that one, kubectl apply -f svc. Got created, kubectl get svc. So here a node port kind of service got created, and we can access this, and also the cluster IP got created, but For this node port, we require the node IP address. So run the command IPA. Here we need to get the port node IP address to the curl IP address, and we have the port 3001. Yeah, so we are getting this output, and let's try to run for the 3002. It's not running. So here we have given the port number, and 3001 we have given it because we have mentioned in our file. If you will not specify this 3001 port number, it will automatically pick the port number ranges from 3000 to 3276 uh, 277, I guess. Okay. Now check the third, that is the load balancer. Okay, so this it was 3000 to 32767. 32767. Okay. The third is the load balancer type. Just delete that. Edit the file. Kubectl apply. Now the node port got changed from to the load balancer type. So how we can access it? So for this we can run the kubectl describe svc and this name of the service. So here you will find endpoint IP. So for this we can just use the curl command and run that, and here is the output. Okay, so for all three types we have just checked out how we can access it, and how we can access our deployment created in the Kubernetes. Okay, so next is the Kubernetes dashboard. uh, Kubernetes dashboard is a web-based Kubernetes user interface. You can use dashboard to deploy containerized application to the Kubernetes cluster, troubleshoot your containerized application, and manage the cluster resources. You can use dashboard to see an overview of application running on your cluster, as well as for creating and modifying individual Kubernetes resources like deployments, jobs, etc. For example, you can scale a deployment, initiate a rolling update, restart your pod, deploy a new application using a deploy wizard. Dashboard also provides the information on the state of Kubernetes resources in your cluster and on many errors that may occur. So if you can see, we can also monitor the CPU and memory utilization of each and every prod, and apart from that we have lot many options. So in this figure also you can see we have the cron job, daemon set, deployment, jobs, pod, all these workloads, services, configs, and storage. Each and every option we can manage it from the Kubernetes dashboard side. Thank you so much for seeing this session. I hope this will be helpful to all of you. If you have any doubt, you can just mail me out or just give the comment below. I will definitely give you a reply. Thank you.